Okay, we're doing exercise 11D from the first year mechanics textbook. And we got a question where we're told a particle is moving in a straight line. We're given the initial velocity, so the velocity is 0 when t is 0. And we're asked for an expression for the velocity when we're given the acceleration. Okay, so to get velocity from acceleration, that's going to be integrating. Okay, because you differentiate velocity. So yeah, you differentiate velocity to get accelerating. So I am going to integrate acceleration to get back to velocity. Okay, so I'm going to integrate. So 8t, I'm going to increase the power to 2, and I'm going to divide by 2. I'm going to increase the power to 3 and divide by 3. And I'm not going to forget my plus c. Okay, so even if you've looked ahead and you've possibly realised that c is going to be 0, you still need to include it in your working. Okay, so then if I go back to what they told me in the question, which is when t is 0, v is 0. So if I substitute that in to my equation for v, I've got, well, 4 times 0 squared is 0, 0 cubed is 0. Okay, so it does work out that c is 0. So you might well have just realised that, but you still need to refer to it in your working. Okay, so same for b. So velocity is going to be the integral of acceleration. Okay, so 6 is going to integrate to 6t. I'm going to increase that power to 3, and then if I divide by 3 again, that's going to make it all over 9. And again, even though I can see that c is going to work out to be 0, I still need to just show the working. So 0 would be 0 plus 0 plus c. Okay, so just make sure that you don't just not refer to c, because it might look like you've just forgotten it. Forgotten it should even be there. Okay, so let's move that out of the way. Okay, so there's our 2 solutions. So let's just double check those. 40 squared minus 2. Yeah, brilliant, we're good.